Our favorite, the quadratic formula. Okay.
Hey, that's what we're programmed for.
So the quadratic formula will solve any problem that has a square in it. So some people are like, well, shoot. Yes, it will solve as long as you don't make a mistake in it. But
Solve all my problems.
it will not solve all of them, but any of them have an x squared in it as its lead term.
Dude, I should be selling this program.
Dude, you should.
I have.
All right, so the quadratic formula. If a problem has a squared in it as its lead term. So if ax squared is the front, and bx is the middle, and c is the end, and if it's equal to 0, if that's the form, and there's nothing higher than x squared, then the quadratic formula will always work. So then x equals negative b plus or minus the long square root of b squared minus 4ac all over 2a. So you may know the little song. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, that is the quadratic formula. So if the quadratic formula works for every single polynomial that has a square in it, why don't we just use it all the time? All right? Right, because sometimes factoring is way more simple. And also, although the quadratic formula is powerful and awesome and will work in every single situation, I find that more students will make mistakes with the quadratic formula in simple math. They make a mistake squaring or subtracting or square rooting or reducing. The simple math is what they make a mistake on. So it's usually user error. It's not the error of the formula, it's a user error. So let's look at some of the common mistakes that might crop up with the quadratic formula. Here we go. Here's our first question. Solve x squared plus 3 equals 10x. You only want to use the quadratic formula if the star doesn't work. If the star works, it's a much easier and usually safer way to find the answer in terms of making fewer mistakes. But the star doesn't work all the time. And so here we would want to put negative 10x in the middle term and then 3 at the end. So it's important that they are in order. We check the star. What number would be in the top? 3 in the bottom? Negative 10. And there are no values that will make that star work. And so we have to use the quadratic formula. And so we'll identify what position will the 3 be in. Okay, C. And then the negative 10 is B. And what do we use as the value for A, even though it's not explicitly in the question? 1. Okay, just because it's, hey, it's not there. It is there. It's implied that the number is 1. Okay, and so then we will solve x equals. So x equals negative b. That'll be negative parentheses negative b plus or minus the square root of parentheses negative 10 squared. In my experience, students who use parentheses are less likely to make a mistake. Minus 4 times a, which is 1, and c, which is 3. All, right, over 2a, which is 2 times 1. So when we clean that up, at the beginning, we see a double parenthesis, or a parenthesis that's got a double negative. So that'll be 10. The first place people usually mess up is on the square, especially with a negative number. Because if you type in negative 10 squared into your calculator, it's going to tell you negative 100. That is not correct. If you type in negative 10 parentheses squared, you get positive 100, which is correct. Anything squared is a number times itself. So if you're squaring negative 10, you're squaring negative 10 times another negative 10. Two negatives always make a positive. So a squared value should always be positive. Well, my calculator told me negative. Well, your calculator, it's a user error. You didn't put parentheses around it. All right, minus 12. Okay, and then all over 2. So we simplify this. Most people usually get the subtraction right. It's the square root of 88 over 2. Now comes the chance to simplify the square root. The closest square root to 88 is 81. 88 doesn't have a perfect square root, but it can be simplified. Are there numbers that can simplify 88? What would go into 88 that would be a smaller number, a smaller square? 4. So 4 and 22 are the 2 square roots that make up 88, which means 4 can simplify. So I'll have 10 plus or minus 2 rad 22 all over 2. And this is the final place where people do fake math. So we've had, serious, it happens all the time. What will happen is fake math people will cross out the 2's and then move on.
Only the real ones.
Yeah, that's fake math. You can't reduce with a plus or minus like that. So instead, the correct way to approach that is the breakup. All right, such a sad story, the breakup, but you need to break this problem up. It needs to be 10 over 2 plus or minus 2 rad 22 also over 2. You need to break up that problem into 2 pieces and 2 parts. The plus or minus separates, and each 2 goes in the denominator. You've got a 2 in both. That's called common denominators, and you break it up. Then you are more than welcome to reduce, but only after a breakup. And so then you've got 5 plus or minus rad 22. Just keep asking yourself, I can't reduce until after a breakup. Okay, after a breakup is when I can reduce. All right, let's try one more. So we're going to solve this time the square root of 5x minus 1 equals negative 4x squared. Now what's intimidating about this question is it has a square root in it already. That's okay, never fear. Okay, you guys are the champs and you can do this. We're still going to set it equal to 0. So what's the proper order going to be, Todd? What's the proper order going to be? 4x squared's got to go in the front. And then the rad 5 has an x on it, so it's going to come second. And minus 1 will come last. And so now we can identify for sure star's not going to work here because the star top is negative 4 and the star bottom would be rad 5, and that's definitely not going to work. So we want to identify that our C value is negative 1, our B value is rad 5, and our A value is 4. So now we're ready to use the quadratic formula. Please use parentheses. So we're going for negative parentheses rad 5 plus or minus the long square root also of parentheses rad 5 with a square on the outside of the parenthesis minus 4 times another 4 times negative 1. And that's all going to be over 2a, so 2 times 4. So my habit is every letter gets parentheses around it to start, and you are more likely to make fewer mistakes if you've got that. So now I'm ready. The negative can go with the rad 5 just fine. And under the long square root, when I have a parentheses around something that's already a square root, but then I put a square on the outside, what happens to the square root? It's just 5. The square root 5 squared is just the number 5. Plus, because you've got 4 and 4, negative 1, so it's going to be plus 16 all over the number 8. All right, then we've got negative rad 5 plus or minus rad 21 all over 8. Okay. Okay, now here comes the next place where fake math happens often. What's negative rad 5 and rad 21 combined together? Negative rad 5, and we'll do plus the first time, plus rad 21. What do you get? Okay, so people, okay, it's going to be 16. Okay, that's fake math. It's not 16. You can't add square roots together. Square roots cannot be added one to the other. They're not like terms. And so that is actually the final answer because you can't add square roots to each other. And so you stop there. So don't go further and do fake math. Okay, you could break it up, and I would accept that as well. And the breakup would be negative rad 5 over 8 plus or minus square root 21 over its own 8. But there would be no reducing because there's square roots into the number 8, and so that doesn't reduce. So you can break it up, but you can't add it together.